All right, so we're going to jump in and take a look at this practice exam that I gave you. Question number one. So the question is, torque is the rotational analog of, well, it turns out the answer is force, but we haven't covered this yet, so sorry. Now, an object slides off a roof 10 meters above the ground with an initial horizontal speed of 5 meters per second. We want to know the time between the objects leaving the roof and hitting the ground. So it falls from a height of 10 meters. This horizontal speed has no effect on its vertical fall time. So we need h equals 1/2 gt squared. So 2h over g under a square root. That's going to be 20 divided by 10 under a square root, and that's going to give us square root of 2 seconds, which is c. Now here, t is 2 pi square root of L over g. And now what we're going to do is we're going to actually replace the bob with a new mass. Since mass doesn't actually affect the period, the answer is C. So the period remains unchanged. Now we have a question of two cars. So we have car Y going this way, and car X going this way. So we want to ask which of the following is true at time equals 20 seconds. So at time equals 20 seconds, they have the same speed. So let's see. None of those things are any of the choices here. So let's see what else we can calculate. So car Y, let's see how far it goes. So car Y, we measure the area under the V curve. That's going to be 1/2 times 20 times V naught, which is 10 V naught. And car X, that's going to be 20 times V naught, and we get the area under that rectangle. So, since car X traveling speed passes car Y at that time, so that's car X passing car Y. So car X is still ahead of car Y since it's covered more distance. So that means car Y is behind car X. Now, from time equals 0 to 40, area under both curves are equal. Therefore, to the following is true at time equals 40 seconds. Finally, car Y is able to pass car X because it catches up to it. All right, here we have V equals t squared. And we want to know the net force is a function of time. So acceleration is 2t. So force is proportional to acceleration. So force is going to be proportional to the time. So we need a linear graph, which is E. All right, now for power, power is work over time. So the power supplied by the lifting force is going to be mgh over t, which is choice B. Here we want to know the tension in the string between the blocks. So we know F minus T equals 2A. We also know that T equals 1 times A when we set up our equations. So let's actually try to figure out what this tension is. So we know F minus 1A equals 2A, so the F equals 3A. Tension equals 1A, so when we compare, tension is 1/3 of F. All right. Now, let's see. We want to look at the momentum of this system when the speed is V. M2 is bigger than M1. So we have the system moving like this. So we're going to have M2V for the momentum of the second one, and negative M1V for that we're going to call the direction of M2 the positive direction. And so what this means is that our total momentum of the system is going to be M1 minus M2V, which is choice B. Now, how has the potential energy of the system decreased? Well, let's be clear. One is lowered, M2GH, and the other is raised, M1GH. So that's how we're getting choice A as our answer. It's the difference in their potential energy change. All right, number 11. We want to know which force will cause the greatest change in kinetic energy. So force does work. So what we really want is the area that gives max work. So area that gives max work. So let's get some areas here. So this is going to be half. This will be half. This is going to be less than half. This is going to be half. This is the one area that's greater than a half, so it's choice E. All right, number 12. We have a mass oscillating on the end of an ideal spring, and we want to know which statement is true. They're not the kinetic and potential are not equal at all times. They're not constant. This is not when we get maximum potential energy. Now, the maximum kinetic and potential energies are equal, but they occur at different times. That is absolutely true. This would be true if this were the maximum. If we change the word kinetic to potential, then E would be true. A person pushes a box at a constant speed of 0.5 meters per second. Box has a mass of 40 kilograms with a coefficient of sliding friction of 0.25. The power supplied to the box by the person. So F times V equals power. And in this case, we're applying the net force in this box is 0. So we know that the force of the pushing minus friction equals 0. So the force of pushing is going to be mu times 40 times 10, which is going to be 1/4 because it's 0.25 times 40 times 10, which is 100 newtons. So the pushing force of the person is 100 newtons times 0.5, and that's giving me 50 watts of power. That's F times V. All right. Then number 14, we want to know the amplitude of the harmonic motion of this block. Here we're going to need to use conservation of energy. So this is going to be mgh, actually, so mgx equals 1/2 kx squared, because it'll actually descend and lose all of that energy, and it'll get converted into spring energy. So this x cancels, and so we're going to give 2 mg over k equals x, and that's going to be 2 divided by 40, which is 1 over 40 meters, choice A. Now, we want to know the period. So the period is 2 pi square root of m over k, which is going to be 2 pi times the square root of m, which is 0.1, divided by 40, which is going to be 2 pi over 1 over 400, which is 2 pi over 20, which is pi over 10, which is C. Right. A particle moves. We want to know which might be the velocity of the particle. So this is clearly a cosine graph. So V is going to be 4 cosine of, and let's just figure this out. So let's get the, so again, let's figure out what the argument is here. So I need the argument. I need 2 pi to be here. I need 2 pi to be my argument when t equals 2 seconds. So 2 times x equals 2 pi, and the x is what we're going to be putting here. Okay, so x is going to be pi, so this is 4 cosine pi of t. That way when we get 2 seconds, we get 2 pi as our argument. We complete a full cosine. So, sorry, this is x as a function of time. Now, v as a function of time will be the derivative, so that'll be 4, negative 4 pi, sine of pi t. And that's choice D. All right, number 17, we want to know the tension of the slanted cord. So here we go. We know that T sine 30 equals 100 newtons. So that means T is going to be 200 newtons of force when we actually set up our free body diagram. And then here, the kinetic energy is proportional to what? Well, V is 3/2 times t to the 1/2. 1/2 mv squared means the kinetic energy is proportional to t to the 1/2 squared, which is plain old t. All right, number 19. So we want to know the period of this motion. So the period is t equals 2 pi square root of m over k, which is going to be 2 pi square root of 2 over 50, which is going to be 2 pi over 5, which is going to be 0.4 pi, and that's choice C. The maximum velocity occurs where? No, no, no. Yes. It's where the displacement from equilibrium equals 0. That's where we're going the fastest. All right, so that's the multiple choice section. We'll do the free response in another set of videos.